Hello guys, welcome to our second video of organic chemistry. Today we're going to be still looking at chapter 1 of organic chemistry. It's the last video for chapter 1. And we're going to be looking at charges, ions, hybridization, and geometry. How hybridization is spelled, I always forget how to spell it. I should make how you see Monster Inc. at the end of the movie, wherever they make the bloopers. I should make a video of that because I have so much bloopers for the last video and this video. Okay, so let's start. Electrons are negative charge, right? In a molecule you have electrons, you have protons, you have neutrons. So in the nucleus you want to have the protons and the neutrons, and that makes the mass, the atomic number is the protons, and the surrounding is the electron count. But this is the stuff that we should know from chemistry 1. So I'm not gonna go really into it. I'm gonna give a quick review so I can start into my subject. So electrons are negatively charged. How I remember electrons being negatively charged is by the Spider-Man villain Electro. He's played by Jamie Foxx, and he's a billion. So billions are bad. Electrons are negatively charged. Protons are good at what they do. So protons are positively charged. So for having a neutral ion, you need to have equal number of protons and electrons, so the charges cancel each other. And neutrons are neutral, alright? So charges will represent when something doesn't have an equal number of protons. Charges is for an unequal balance of protons and electrons, right? So positive, whenever an element has a positive sign, it means it has more protons and electrons, which it means that it's missing electrons. So positive ions are called cations. A way I remember cations are cat, and cat has pas, and these are positive. So they are positive. So I just remember that. And anions, I remember, I don't want to be here, but as long as you know cations, anions will be the negative one, right? So anions, they have extra electrons. Only the number of electrons changes. Protons, the cations doesn't mean they have more protons than like a normal carbon, right? It means that it has less electrons compared to the number of protons. Because if it had more protons or less protons, we will not be dealing with the same element. We will be dealing with a different element. Because as you remember in chemistry 1, the number of protons determines the atomic number, which determines the molecule. Okay, so hybridization. A hybrid is a combination of two things, right? So how I like to think of hybrids are, I used to work in a mechanic shop in Houston, and there is this type of cars that can run both in gasoline and in electricity. And those cars are called hybrids. The older models are not that good, don't buy one, but that's not the point right now. So it's like a combination of electricity and gas in a car they call hybrids, right? So how does this go into chemistry? Well, Jesus is about to explain. So we have the S block and we have the P block. The SP. And to reach the carbon, you go to the S block, after you go to the P block, right? We're not going to go to the whole process of how this happens, or the hybridization, right? This is like a simplified thing. Like you go from the S to the P, and your carbon is gonna be sp3. There is more blocks and there is elements that have different hybridization, but we're only going over carbon hybridization today, right? And here is the F block, right? So if your carbon has 4 bonds, 1, 2, 3, 4, then that's what you expect your carbon to have, unless it's a cation or an anion. Your carbon should be sp3 hybridized. A way I like to remember is that sp3, so you have 3 p's and 1 s. 1, 2, 3, 4 bonds, right? So one of these bonds go missing, it will be a sp2 hybridized, and you're gonna have two p blocks and one s, right? If one of them goes missing, it's a sp, and it's a linear, so you're gonna have two bonds. Geometry. I think we all took that class in high school. Well, so geometry, as long as you're doing hybridization, right? You can know the geometry if a carbon has two bonds, sp hybridized, and the geometry is linear. What does this mean? That the geometry is linear. Like imagine this cap is your carbon atom, right? So the geometry is gonna look like this. That's what it means, the geometry of the bonds. So it's linear, like a line. sp2 hybridized, so we have three bonds, right? And it's trigonal planar. What does this mean? This has like, it's not 3D, it's just like a triangle, trigonal planar. 1, 2, 3 bonds. So in trigonal planar, sp3 hybridized, tetrahedral. It's going to be the 4 bonds. What's a tetrahedral structure looks like? Well, a tetrahedral structure looks like it has a base, right? And after that, something is sticking out, right? So it's gonna be like 1, 2, 3, and something is sticking out. That's how a tetrahedral looks like. It's represented in textbooks like a little pyramid. That's why it's called, and it's like 4 bonds. So these are the 3 geometries that we can get for carbons. This is important to organic chemistry because carbon is the elements with carbon are organic molecules. So knowing the hybridization of carbons and the geometry is very important, really important for other chapters. 1, 2, 3. So that's a methyl group. Okay, so it has a plus charge. So how do we call this? We call it cation, which means it's positive. Why is this molecule positive? Why is it positive? Because it's missing an electron, which means it has more protons, and protons are positively charged, right? So how many valence electrons are in this carbon? Pause the video and answer it. So if we're missing 1 electron, that means we have 3 valence electrons. With how many bonds we have? 1, 2, 3. So what's the hybridization? The hybridization is sp2. If the geometry is sp2 and this looks like a little triangle, what's the geometry? Planar or trigonal planar. So this is everything for this video. I hope you like it. I think it's a little bit better than last video. Let me know what I can do to improve.